We don't do a whole lot of community engagement and citizen science projects, and we had the opportunity to do this one, and we really enjoy it. We've really enjoyed working with Friends of Oakdale Lake and all the partners for the last, going on 5 years now, and we really, we like to brag about this project. We think it's a lot of fun, and we think it's been very successful. And we're gonna go right back to the beginning. A little introduction to the project. So we did a presentation at the end of phase 1, and as Tamar said, this is now phase 2. There have been 2 separate grants from the state to do the work. At the end of phase 1, we did a presentation. But I'm going to go back and review a little bit about that. So phase 1 began in 2020, and in phase 2, which is now concluding, began in 2023. And it included a continuation of some of the work we did in phase 1, but it also brought some new elements to the project. So implementation, as Tamar said, of some recommended actions, which we'll talk about. I want to acknowledge the funding for the second phase of the project from New York DEC, Department of Environmental Conservation. They have an environmental protection fund, and within that, there's an environmental justice community impact grant, and that's the source of the funding for this project. And I want to acknowledge the guidance of the project from Columbia Land Conservancy and also Friends of Oakdale Lake. We've been working hand in hand with all together on that project. Very collaborative, which makes it fun. So the components of the project of phase 2 include a citizen science water quality monitoring program. There's an image of some of our scientists here, and that continued from phase 1. We did benthic macroinvertebrate surveys. Macroinvertebrates are the organisms that live in the sediments, and they're a good sentinel of conditions of the lake, and we surveyed those for 2 years. And we also did surveys of submerged aquatic vegetation, not the algae, but the actual plants, the submerged plants, the higher plants that grow underwater, and they're also a very good indicator of environmental conditions in aquatic systems. We did a pilot study using barley straw to see if we could manage some of the nuisance algae depicted here that accumulate kind of just off the beach inconveniently at the lake. We tried that for a couple of years. Before, we did that as sort of a pilot to see if we could get a handle on it before recommending more, I don't want to say extreme, but involved interventions like algicide, although we are now considering that. I don't want to jump to the end. And all this information goes into an ecosystem model. We have a modeler at our disposal, and he takes all the data we collect, and it's a little black box. We do a lot of computer modeling, and he comes up with predictions and tries to forecast the response of the lake to changes such as nutrient loading, but also the interventions that we've suggested and implemented. And then finally, we end up with suggested management alternatives. So we had some management alternatives we suggested in phase 1. We implemented those. Now we're observing the results of those, and we're going to make some additional recommendations at the conclusion of phase 3. Well, background, if you're not that familiar with the history, Oakdale Lake, artificial lake, of course, created in the early 1900s by damming what's known as the power strip at North 6th Street. The current land use, it's urban, suburban. There's a lot of impervious cover in the watershed, up to 40%. Impervious cover is things like parking lots, building roofs, streets, and so on. So that impervious cover can be a problem because it encourages runoff directly into the lake. But there is a fair amount of natural cover as well. There's about 30% of forest that surrounds the lake. So that does a pretty good job of intercepting runoff as well. So it's about half. And then there's a few other land types like mowed lawn, of course, built the water of the lake and the beach. We did a bathymetric survey. That's a survey that maps the depths of the lake. So if you use the lake, if you swim there, if you fish, if you kayak there, you probably have a good sense of where the deep parts are and where the shallow parts are. But we needed, again, to model that, to do the modeling, we need to really understand the depth contours. So we hired a company. They came out and they did a bathymetric survey with an echo sounder. And as you can see, the back end of the lake is very shallow. It's less than 5 feet. It's a little deeper, 5 to 10. And then the deep part is kind of right off the beach. Obviously, that's where they put the swimming, the pier, the platform, dock, whatever. It gets to a maximum depth of 18 feet there. So it does drop off pretty quickly as you get off the beach. And again, if you swim there, or if you fish in the lake, you probably know that. If not, now you do. Again, a major element of the project from the outset is training citizen scientists, volunteers within the community to do water quality sampling. There's an image of Kate. She's there early on, explained to everyone all the different types of samples we collect, how they're bottled, how they're packaged, how they're shipped to the laboratory. There's a kit that we provide, and we've done several events sort of on a monthly basis since 2020, collecting data. It's been really, really consistent and great data. We're collaborating with an organization called the Upstate Freshwater Institute in Syracuse. They're a testing laboratory, research facility, and they've been doing all the actual laboratory analysis of the samples we collect. So it's been a real success. We've had a lot of good participation from members of the community in this. It's been great. Just some images of that. There's a group, actually a little anecdote. This young lady here, she's done it quite a bit. She's come out a number of times. Kate's laughing because she knows where I'm going with this. The instrument she's using, the device, it's called a Kemmerer bottle. And it's a plastic bottle with some gadgets. And the idea is you drop it down and you send a lead weight down called a messenger. And when it hits the top of the bottle, you've got it, this is measured off on the rope. And so you know exactly what depth you're at. When the messenger hits the bottle, it pops the springs and closes it. So you get a sample of water that's not integrated across the depth of the lake. You get a sample of water from exactly where you want it. So if you want a sample at the bottom, you drop it to the bottom, send the message down. If you want it in the middle, again, it's very precise. But it's tricky to get it to work because once you've sent the messenger down, you have to give it a tug to get it to actually close properly and collect the sample. And adults can't seem to do it, including myself. Let me try again. Let me try again. You're there for an hour trying to get this young lady. I don't know. She had like the feel. She was the bottle whisperer. Every time she went out, first time, boom, she got the sample. So yeah, it was just I don't know. She had the magic touch. She should be an oceanographer when she goes out. Maybe she will. Anyway, these are the stations. So we had two stations, one in the back, one kind of near the deepest part where we collect the water. And we kept those stations consistent throughout the 4 years of sampling. Okay, a little bit about the modeling now. I'm not a modeler. It's a little black box to me, but it is important. I just want to talk about it a little bit. The model called Aquatox, and it was developed by the U.S. Environmental Protection Agency, EPA. And it's used to study the interactions of nutrients, contaminants, and all other inputs to Oakdale Lake, not Oakdale Lake specifically, but to aquatic ecosystems. And we thought it was going to be very handy, and it was, to sort of predict and guide the project. So it simulates different processes within the water in response to stressors or management actions. So you can tell the model, we're going to oxygenate the lake and then see what's going to happen a year or two down the line. Or you could say the lake is going to receive more pollution over time. And so the model spits out a simulation. You can set all kinds of different scenarios, and you can do it over a matter of days up to decades. We tended to do it on several month basis, but it did a good job. The model, the conditions that the model predicted were generally in line with the observations we made with the water quality sampling. So we're very confident, and we thought the model was a helpful tool in guiding the program and also helping us develop management recommendations that we think are sound. Here's some of the things we plug into the model. So temperature, dissolved oxygen, pH, turbidity, it's the cloudiness of the water, nutrients, chlorophyll, a whole variety of different measurable parameters that we collected data on throughout the water. Again, the citizen science program, it was robust. We collected a lot of really good data over the 4 years. Very valuable. And some of the other things we plug into the model are some sediment characterization. Again, the benthic invertebrates and the submerged vegetation. And then the bathymetry data also factors into the model. Hydrology and weather. So it's a pretty sophisticated tool to predict conditions. Okay, it's a little dense here, but I'm trying to break it down. Results. Yeah, we get right to the results. Phosphorus. Phosphorus is what we call a limiting element in freshwater aquatic ecosystems. So we're very concerned about phosphorus because inputs of phosphorus tend to put lakes and ponds and other aquatic systems at a severe risk of what we call eutrophication. Eutrophication just means over-enriched. In 2023, the total amount of phosphorus that we measured in water samples exceeded a threshold, 0.03 milligrams per liter, and that's the threshold at which scientists have decided that's eutrophic. That's 70% of the time. In 2024, total phosphorus exceeded the threshold at 100% of the samples. So the lake is eutrophic, it has been, and will continue to be eutrophic, for some time. That doesn't mean the lake is dead. Actually, it's quite the opposite. The lake is maybe a little too alive. But it's something that we have to be concerned about. There's a pretty constant and consistent loading of phosphorus in the lake, and most of it's probably in the sediments, and it's been there, and it's going to take a while for that phosphorus to be used up by biological processes. You could short circuit that by removing the sediments from the lake, but that's drastic and disruptive, and we are certainly not recommending that. But in some cases, that's the only alternative. Lakes get dredged, you see that, and it's because there's no other alternative. We're not at that point at Oakdale. Now, in 2020 and 2021, so phase one, the eutrophication level was exceeded between 50 and 80% of the time. So it does look like there's more phosphorus in the water right now. And there's some reasons why that might be taking place. There's all different sources of phosphorus. It's in fertilizer, it's in pet and animal waste and detergents. It's naturally occurring in soils. The other thing is groundwater is a potential source of phosphorus. So we know that groundwater is an important contributor to Oakdale Lake. It's spring fed, and so we may be just seeing a constant input of phosphorus through groundwater that we probably can't control. We can control a lot of these things. We can control fertilizer, we can control waste and detergents, but we can't really control groundwater input, so that's something to be concerned. We just may be dealing with a constant natural input of phosphorus in the lake, in addition to all the other sources. However, here's another thing. Phosphorus that's locked up in sediments is released more readily under higher conditions, higher temperature conditions. And we've been seeing higher temperatures on average, and we're going to continue to see higher temperatures on average. So I've got this bolded and highlighted because this is going to come up in the rest of the talk a little bit. This is a concern. We can do a lot of things to intervene here and to control phosphorus, but as temperatures increase, annual temperatures, high summer temperatures, this is going to be increasingly a challenge that we're going to have to deal with. Nitrogen. So I mentioned that phosphorus was the key nutrient in aquatic systems we conserve. Nitrogen is also a nutrient in aquatic systems. However, it's less important in controlling eutrophication in freshwater systems. Now, if this was a marine system, like a coastal bay or a tidal river, for example, we'd be more concerned about nitrogen. It sort of flips. In marine systems, nitrogen is the problem, much less phosphorus. But in freshwater, nitrogen is something to keep an eye on, but it rarely is implicated in the problems. And in fact, the nitrogen levels that we're seeing, very low. EPA has an acceptable level of nitrates in drinking water, for example, 45 milligrams per liter. We don't see anything approaching that in Oakdale Lake. We don't even see anything in that order of magnitude in Oakdale Lake. So we really don't have too much of a concern with nitrogen, but we do continue to track it. Ammonia is a form of nitrogen, and ammonia is toxic. Ammonia can be toxic to aquatic organisms like fish and vertebrates. It can be toxic to submerged aquatic plants, but again, we generally don't see very high ammonia levels in Oakdale Lake there. Now, one thing we've noticed, which is an improvement, is that the ammonia levels we did observe were a lot lower in phase 2 than in phase 1. So there's potential indicator of improvement there. And the question is why? Why are we seeing that? Well, when you have high oxygen concentrations in the lake, which you can have for a number of reasons, plankton blooms naturally produce oxygen. Even though plankton blooms themselves are problematic, they do contribute, they do oxygenate the water when they're blooming. Problem is when the plankton dies off and all the dead plankton sinks to the bottom of the lake, it actually uses up oxygen. So that's sort of a balance. However, as you may know, if you've been out to the lake, we've been oxygenating the lake artificially with aerators. And what that does is it promotes a conversion of ammonia, which again is toxic, to nitrite, which is just a different form of nitrogen, but is not toxic. So we may be seeing some benefits immediately from the oxygenation, the artificial aeration, resulting in lower ammonia. So that's a good indicator. Here's some of the output of those models I was talking about. So the model spits out graphs, and then you have to look at the graphs and scratch your head and say, what's going on? And in this case, you definitely see some patterns. It's usually peaks and valleys. So the red line is phosphorus, and the green line is nitrogen, and they actually track pretty well with each other. And what you tend to see, it's a little confusing because our modeler is European, he's from Spain, so he uses this European thing. At first I looked at that, and it didn't make sense, but it's actually, this is September, this is July, this is, so if you're looking at that, you're confused. But what you see in late summer, or actually midsummer, very high peaks of phosphorus as well as nitrogen, then a drop, and then you see another peak in the middle of winter, January, and then drops again, and then in the springtime, early summer, you can see. This is typical. This is a typical cyclical pattern. It's not constant. The nutrients come and go. There's reasons for that. And there are some differences between the numbers that the model predicts and the actual values that we measure. But there's some explanations for that. The model doesn't take into account stormwater, for example, apparently. But the differences were minimal. The model did a pretty good job of tracking what we actually saw out there. Okay, let's talk about a few other indicators. Dissolved oxygen, I mentioned, is important. When you have high photosynthetic activity, like blooms of algae, initially you get high oxygen, like I mentioned, but then what happens is that phytoplankton has a very short life, and it dies off, so it's a bloom, and the cells sink to the bottom and they decompose, and that reduces oxygen. So that's a problem. You don't want that sort of boom and bust cycle. And also, dissolved oxygen just happens to vary time of day. One thing we really haven't done on this project, and if we had unlimited funding and unlimited resources, and we can continue this, I would recommend some continuously monitoring dissolved oxygen levels in the lake. I think that would really give us a good handle on what's going on. We've talked about that, but it's expensive and labor intensive. But perhaps it's something we do in the future. I think it would really help us inform future management. It's just going out there and taking a random oxygen measurements like we do. It's helpful to give you a range or some boundary conditions or some ideas, but if you're not out there all day and all night, and throughout seasons, you're just sort of guessing. It is really important to understand measurements of oxygen on a very frequent level. That's one thing we're lacking. But generally, oxygen, pretty good. Even though we're adding oxygen through the aeration, which I'll talk about. There aren't really a lot of indicators that the lake is what we call anoxic or hypoxic, which is chronically low oxygen. Maybe episodic reductions in dissolved oxygen, but I don't think the lake sets up where it's got excessively long periods of low oxygen, which some extremely eutrophic systems would have. I've worked in some eutrophic marine systems out in Jamaica Bay, for example, if you're familiar with the city, where you have chronic low dissolved oxygen for months at a time, and nothing can live there. It just doesn't support life. We're nowhere near those conditions right now. pH is something else to be concerned about, although not in Oakdale Lake. We have very good pH in Oakdale Lake. Oakdale Lake happens to be very well buffered. The bedrock underneath the lake has a lot of limestone, and the calcium limestone buffers the pH. So if you have a pool, you know what I'm talking about. I struggle with my pool. It's constantly low pH because of rainfall. Rain is acidic in the northeastern U.S. It has been for decades. And if your watershed isn't buffered, like places in the Adirondacks, vast reaches of the Adirondacks have very poorly buffered. They have acidic soils. They don't have limestone, and so you have a lot of lakes that have extremely low pH. They're very acidic in the Adirondacks, and that leads to basically extirpation of fish communities. You have a lot of lakes in and around that want to support fish, but do not. But Oakdale Lake, very well buffered. Every time we've gone out and measured pH, it's been very neutral or slightly basic. And so that's definitely something we don't have to worry about. It's protective against acidification from runoff and spring, and that's a good thing. It's protective of aquatic life. Oh yeah, forgot about that. Here's my recommendation. Monitor dissolved oxygen continuously for an entire year to identify episodes of oxygen depletion. That's what I was trying to say. Let's talk more about phytoplankton, because I've mentioned it a few times. If you're not familiar with it, it's floating single-celled plants, and they represent the base of the aquatic food web. A lot of small organisms like crustaceans and larval fish, they eat phytoplankton. So it's really important to have phytoplankton. The problem is you just don't want too much of it. And that's what happens when the lake is eutrophic. They bloom. And you can see, the water has sort of a greenish cast to it. So they're sampling in the midst of the phytoplankton right there. Lake doesn't always look like that. Sometimes you go out to the lake and it looks rather clear. Other times it has that pea green soup. Of course, late spring, early summer, early fall is when you tend to see the blooms fall. And there's always like an early summer bloom, but then there's usually a secondary bloom at the end of the summer, early in the fall. Okay? And they can last for days or weeks. But like I said, they die off, they settle at the bottom, and then as they decompose, the decomposition just takes oxygen right out of the water. But the phytoplankton community, when we actually go in, and we did do this, we go in and we actually identify what species of phytoplankton are present. And that's important because the different kinds of algae have different effects on the ecosystem. So here it's dominated by just what they call green algae. I know that sounds very vague, but that's actually the taxonomic term. It's a type of algae. And diatoms. And that's good because there are other types of phytoplankton that are not that beneficial. And we'll talk about that in a second. But we measured water clarity during phase 2 and also phase 1. And oftentimes, the way we measure is we actually take a device called a Secchi disc. All right, let's see if I can describe this. Did you ever go to the city and get those big black and white cookies? Right? You know what I'm talking about. Go to the Zaros or whatever. They look just like that. It's a disc that's black and white, and you drop it down. And when you can't see the distinction between the black and the white, and when the disc basically disappears, that's what they call the Secchi depth. It sounds simple, but it's been the standard for measuring the transparency of water for decades, many decades. Anyway, the water depth of the transparency was often less than 6 feet. That's because of the phytoplankton. So, that's another indicator of eutrophication. If you can't see more than 6 feet down, you got a phytoplankton. Now, this gets confusing because you hear algae blooms and you hear a lot in the press about harmful algae blooms. That's different. That's a different type of algae called blue-green algae, and technical term is cyanobacteria. That's harmful because those organisms actually produce and give off some toxic compounds. Okay, and when I say toxic, I mean toxic to fish. It can be toxic at high concentrations. It can induce respiratory problems or sort of a neurotoxin effect, mild, but in extreme conditions, people have gotten sick from this. Pets oftentimes get sick from this. So when there's a harmful algae bloom, the health department will usually put up a warning and say, don't swim in the lake and don't let your pets swim in the lake because they're at risk for getting sick. And that happened this year at Oakdale Lake. It's probably happened in other years, but not to the extreme that it happened this year. It's a pretty bad bloom this year. We didn't see it in other years, or it was of such short duration that we didn't notice it. We're not on the lake every day. It's common in other lakes in and around Hudson Valley. There are a number of lakes in Columbia County that chronically get cyanobacterial blooms every year. But we were concerned about it this year. However, again, back to this, elevated water temperatures. Summer 2024 was hot. Hot summer. And we didn't have those kinds of temperatures in the previous years of study. So, frankly, it's not surprising that you had a harmful algae bloom in 2024. And this is what it looks like. So this is the difference. So when you see just pea green water, that's not a wallflower bloom, that's a regular phytoplankton bloom. And when you go out to the lake and you see what looks like someone took green paint and spread it on the surface, because it floats. You get this is actually not taken from Oakdale Lake, this is from another lake, but that's what it looks like. So if you go out to the lake and see this, that's very indicative of wallflower bloom. And we, in fact, can see that. So there's sort of the backwater part of the lake in late August. Clearly, again, it's got that painted kind of look to it on the surface. And yeah, it's a definite wallflower bloom. And then as it dissipated, it still left a sheen on the surface of the water, but it sort of died off. It became less green, more transparent. But yeah, and it was the right call for the health department of the town or whoever to we closed off the bathing beach for a few weeks, I think it was. Abundance of caution. I don't think it was as bad as to, I don't think anyone's going to get sick from it, but abundance of caution. And frankly, we may see these in the future. If we continue to have elevated summer temperatures and increasing summer temperatures, this is just something we're going to have to expect to see. And so last year's closure was unfortunate, but it's probably something that we may see in the future. And again, nature is variable. I don't know. So far, we're having a pretty cool spring, right? I don't know what the summer's going to look like. If we have a cool summer, we may not set up those conditions to have another wallflower bloom. But if it gets warm again, if we get a big heat spell in late July and August, it's quite possible this could happen again. Extremely variable from year to year. Here's some modeling that talks about the response of the phytoplankton to nutrients. So what you want to be concerned about here is you've got the red peak, which is the nutrients, and then it's followed very quickly by the nutrients stimulate the phytoplankton. And you get a blue lockstep. And this is consistent year after year. You get your high levels of phosphorus, and then within weeks or even days, you get that very, very sharp bell curve there. That's your phytoplankton. But then they die off very quickly. Here's where the oxygen would be low. Now, here's a question. So we see a peak here in nitrogen, but then there's a peak here in, phosphorus. How come there's not a corresponding phytoplankton bloom here? Anyone want to take a guess?
It's cold.
Because it's cold. Exactly. Yeah, so this is the winter. So that's typical. You tend to get another peak in phosphorus concentrations in the winter, but it doesn't result in phytoplankton bloom because you need the combination of nutrients and temperature for phytoplankton blooms to set up. So you don't get that. Exactly. And this is the same thing with nitrogen. Although somewhat through it. You get the peak of nitrogen corresponding with the peak of phosphorus, but it also triggers the phytoplankton. But again, not the winter months. I talked a little bit about submerged aquatic vegetation. You can see in this picture, the entire, this is sort of in the back of the lake, the entire surface of the lake is covered in this vegetation. This is an invasive, it's invasive, non-native species. It's very prolific. It's called curly leaf cottonwood. It provides good habitat for fish. It provides a lot of functions, but it just grows out of control. And the problem is, because it's non-native and very invasive, it outcompetes the native SAV, vegetation. So even though SAV in general is good, but when the non-native species outcompetes the native species, you've got a reduction in biodiversity, and the system's a little out of line. So we consider that a negative. And here's where we sample. So we monitor this 2 years. And stations in the back, and then stations on that spillway, and then off the beach. Here's a picture of the different species. This is the native form. This is called slender pondweed. That's what we'd like to see, and it is present. This is the non-native, what looks like what's out of the water. It's called curly leaf pondweed. It's very distinctive. If you pull it out of the water, the leaves, they look like lasagna noodles. Very, very distinctive. There's no confusing the native and the non-native. And so, like I said, it forms extensive blooms. And what we did in, I believe in 2022 is we actually hired a commercial SAV harvester. We had a company come out and they've got a boat that harvests. So we pulled a lot of this out of the lake. And we thought we'd have to do that on a yearly basis. We thought it was just gonna come back. As it turns out, removing this at the right time, just right about the peak of the bloom, it changed something. It didn't come back in 2023. It came back a little more in 2024, but we didn't harvest that either. We don't, I guess we're trying to decide whether we're gonna harvest this year. I don't know. I haven't actually been to the lake this year. I don't know how much of a bloom. Is anyone? It's not. Yeah, so I think getting it out that in 2022, we removed a lot of the biomass. It just has never come back. So I think that was good. Why do you remove it? What is the benefit of removing it? Well, all this plant tissue has lots of phosphorus in it, a lot of nutrients in that plant tissue, which is great when it's growing, but when it grows and then it dies, just like the phytoplankton. So you get a very rapid die-off at the beginning of the summer. When it dies off, all of the nutrients that are in that living leaf tissue, it just gets re-assimilated into the water column. So you've got this constant loop of plant growth, and then release of nutrients, then uptake of nutrients and release. So by removing a lot of that biomass in 2022, I think we short-circuited that loop, I'm guessing. But we haven't had to do it again. We thought we were going to be doing that every year, and we just haven't had to. And just an example of the natural variability, 1 year, 2023, we had a large bloom of this, it looks just like a submerged plant, but it's actually an algae. It's called muskwort. And you would absolutely look at it and say, that's not algae, that's just a submerged plant. But if you were to walk through it, you can feel it scratchy, kind of like it has a very rough surface. And when you pull it out of the water, it stinks. So it's called muskwort. It has a very musky odor, so you realize that. And the funny thing is, we saw that in 2023. We didn't see it last year, and we didn't see it in 2020 or 2021. We just had a bloom of it in 2023. What that tells me is we really have to consider monitoring for longer periods of time, because nature sometimes does what it wants to do. So these 2-year studies, 3-year studies, they're great, they're informative, but there's really a benefit in having multi-year studies, because you never know when you're going to have something like this. It's an anomaly. But if we only sampled 1 year, we would say Oakdale Lake has a very large bloom of muskwort, which it did in 2023, but it hasn't in any other years. This is why scientists are often hesitant to say something is happening, something's not happening. A good scientist knows that you really need an accumulation or an abundance of evidence, which is only gathered by long-term research. There's an entire government-funded program, National Science Foundation. It's called the LTER, the Long-Term Ecological Research Program, and it's funding that is specifically intended to maintain long-term research sites for decades, so we can really understand how ecosystems work, because it's really tough when we have 2 or 3 years of data to have certainty, about some of the conclusions we draw. The more data, the better, quite frankly. I know it sounds like a scam for scientists like myself, but no, it really is true. And benthic macroinvertebrates. There's one of my colleagues, Chase Matty. He's collecting samples with a dredge off of our little research boat. So we took a dredge sample with sediment. It just looks like black mayonnaise, but when you wash it and clean it up and pick through it, you find all kinds of interesting things living in there, like snails and insect larvae and little crustaceans. That's the benthic macroinvertebrate community. We say, it's a little confusing, we say macro, but they're really kind of tiny. But macro means large enough to be retained on a 1/2 millimeter screen. So we take the sediment and we gently wash it through a screen that's a 1/2 millimeter in diameter. That's what we call macro. Anything that would pass through the screen would be microinvertebrates, but macro is still kind of small. Here are the stations we sampled invertebrates at, just in the back of the lake, and one off the recreation area there, and one kind of in the middle. And the results of that were kind of low abundance overall, and the diversity was kind of low overall. But there's a lot of variation between years. We're not really able to say a whole lot about the macroinvertebrate community because it varied quite a bit from within the 2 years. So you probably need something like 5 to 10 years of study to actually really get a handle on what's wrong here. But we do know what the dominant organisms are. The dominant organisms are insect larvae called chironomids. They're just non-biting fly larvae. They're actually quite common. And they're an indicator of eutrophication. So high levels of these chironomids means you've got to concern. When your sample is nothing but insect larvae, that means you've got a real problem. But we're still at the point where we've got crustaceans, we've got a good representation of gastropods, snails and clams. And snails and clams are a good indicator of water quality. So when you lose your snails and clams, that's when you have a problem. They don't do well under low oxygen conditions. So at least having an abundance of snails and clams. Again, we keep seeing these indicators that the lake has good oxygen conditions, which is encouraging. But we think that there are some disturbance factors that we may not even be noticing. Like we probably do have episodic reductions in oxygen, which high oxygen, that we're not picking up because, again, we're not monitoring oxygen for a very long period of time. That's why if we were to instrument the lake with some continuously monitoring sensors, we might have a better idea of when these disturbances take place. But we think that's limiting the community from being more diverse and even more abundant. There's some certain types of indicator species that aren't showing up in the samples, like dragonfly larvae, mayflies, certain types of beetle larvae. Well, we're just not picking those up, and they're probably excluded because of episodic reductions in oxygen. Now, the model simulation suggested that if the lake becomes more eutrophic over time, we'll probably see even more of a decline in species richness. And we might lose, like, for example, the gastropods. But I don't think we're in any danger of that happening soon. It just doesn't seem that way. Especially with some of the interventions we've put in place, like the oxygenation. And just an example, 2 years of data, and actually looks quite different. The abundances in 2023 were quite a bit higher, if you look at the scale here, than 2024. And again, that's not an artifact of sampling. We used the same exact sampling equipment, the same exact people doing the sampling, and the same exact individual doing the taxonomy. So all in all, everything was consistent, but there's quite a bit of difference in abundance between 2 years. And also, you can see in 2023, the green represents the insect larvae. We had a lot more of that. But in 2024, the mollusks were more dominant. There's more yellow on the screen, which is actually, again, a good indicator. So just another plug for why you really need long-term studies to make solid conclusions. There's some modeling about the invertebrates. Yeah, I know this looks like spaghetti. Let's see, I'm going to sum this up real quick. We, just like the phytoplankton, okay, so the yellow, in this case, is the phosphorus. There's your phosphorus peak, right, in July, followed by a predicted increase in the insect larvae. So the insect larvae tend to be very responsive to changes in nutrients, whereas the other organisms like the crustaceans and the snails, they just kind of, they're steady state or they somewhat decline over the summer. But and the reason for that is the insect larvae are very short lifespans, and they reproduce several times throughout the summer. So they're very sensitive to changes in nutrients and food availability. Whereas the snails and the clams, they're long-lived. They can live for years, and they just tend to not really respond so obviously to changes in things like nutrients. And that was same thing with nitrogen. Peak of nitrogen, and you get your, well, I didn't do that.
I can.
Would you?
Yeah.
Oh, time's out. Okay. There we go. Thank you. Because I would have never figured that out. It's funny because I actually touched the screen and I felt like as soon as I did that, we're almost done. I want to say a few things about fish. We didn't sample fish. We didn't characterize the fish community. It would be a great add-on or a future study. Fish sampling is expensive, it's labor intensive, it tends to be the first thing you take out of a grant because, but it can be very informative. If you fish at Oakdale Lake or you see people fishing there, you'll know that the most frequent species that are caught are largemouth bass, rock bass, pumpkin seed, bluegill. These are all sunfish species, and they're targeted by the recreational anglers at the lake. And common carp are also present in the lake. These are fish species that tend to do well in eutrophic ecosystems, what we call warm water game fish. Now, cold water game fish, like the trout pictured here, they're also in the lake. They were stocked at one point, but there's a lot of evidence that these fish are actually reproducing naturally in the lake. We don't really know that much about it, other than historical records of stocking, because we haven't really done a survey of fish in the lake. There's a couple ways you can do that. You can go out there. The DEC has a standard protocol. They actually go out and they electrofish. They use electric current to, you don't kill the fish unless you do it wrong. You stun the fish, and they go around the perimeter of the lake, and they use electricity to stun the fish temporarily, and then they collect them and they measure and weigh and identify them. And it's, again, if it's done right, it's harmless to the fish. That's one way to do it. Another way is simply to do what we call a creel survey, or you can actually do interviews of people who are fishing at the lake. Go out there repeatedly, ask people, what are you catching? Can you measure some of the fish you're catching? That's actually a very good way. It's like a community, it's like a citizen science type of survey, except it's for fish, not water quality. And a creel survey at the lake, if it's done intensively and for a long enough period of time, that might be a very informative way to collect a lot of data on the current status of the fish community at the lake. And I would recommend that. But back to the trout. The reason why we think they're holding out in the lake, even though the lake is warm and the lake is eutrophic, is that it's spring fed, and you've got that deep part where the water's about 18 feet deep. These trout probably hold out down there in the summer. In the winter, they're probably all over the lake. And I don't know, do people ice fish at Oakdale Lake? Yeah, that would be another opportunity for a creel survey to really understand what's being caught when there's ice fishing. Again, we have these warmer years, those opportunities there become fewer and fewer for ice fishing. I don't personally, I like to ice fish, but I haven't done it in about 4 or 5 years because I ice fish in Saugerties, and we haven't had good ice on that lake in quite a while. We used to have an annual event above the Canteen Dam in Saugerties. The Hudson River Foundation would sponsor it. We'd bring their board members and a whole lot of people out there, and we did it year after year, and we haven't had that event since. It's got to be at least 5 years. So, these warming trends are real, and we're seeing it, and it's going to have implications for survival of trout and frequency of harmful algal blooms and a whole bunch of other things. All right, summary. So, again, scientists don't like to be very decisive, but overall, water quality monitoring and the invertebrate sampling indicate the lake is eutrophic and continues to be eutrophic over the period of study. And there's potential for episodic reductions in oxygen and increasing likelihood of this seasonal harmful algal bloom formation. But again, year to year, there's a lot of variability. However, there are some indicators that point to a slight improvement in water quality and the system's ability to maintain. The lake is probably quite resilient. Lower ammonia, higher dissolved oxygen, a few other things. So the recommendations are that we continue the interventions that we've implemented, which is aeration and then harvesting the SAV if and because necessary. And we recommend continuing the water quality monitoring if there's funding to do it, and to continue doing surveys of SAV, invertebrates, and fish if there's opportunity and funding to do that. The more data, the better handle we're going to have on these conditions. And again, I mentioned eutrophication, but I never really defined it, and here's a good image that defines it. Nutrient loading, algae blooms. When you have too much algae, it dies off, you lose your aquatic plants, you can lose fish. Ecosystem becomes out of balance, and then you end up with, well, in extreme conditions, you just end up with a lake that has no fish, very poor invertebrate communities, no native submerged aquatic vegetation. But we're not there. Like, Oakdale Lake is very far from that condition, and it's holding steady. Some of the things we recommended, yeah, there's the lake SAV harvester. Some of the things we recommended after phase one was aeration and harvesting. We did the harvesting, we did the aeration, we installed a system of 4 aerators. We tried some barley straw to control algae. Didn't seem to work. It works well in small ponds. I think there's just too much flow through in the lake. It's probably just a little too large. The amount of barley we have to put out there would be impossible and unsightly, but it was a relatively inexpensive experiment, and I think we learned something there. We learned, and so now there's some cartoons of the aerators. If you're not familiar with how they work, a generator based on land. If you've been over the lake, there's that shed, that mysterious shed. You wonder what's in that shed. I forget. You can see if you walk down to the concrete pier, look over, you can see the lines running into the water right there. They're actually well hidden, but they're there, and they go out to a system of 4 aerators. There, diffusers, we call these the diffusers. Yeah, so the lines kind of run out here and then there. And you can see them bubbling. And again, in the winter, when there is ice formation, you can see the crop circles that they form. You know, the aeration actually inhibits the development of the ice. Yeah, this is good. I mean, should there be more aeration? Hard to say. And more is always better, but maybe in the future, the system can be modified to increase aeration to other portions of the lake. Or, maybe one thing that actually is used to break up the problematic algae mats, it's not just aeration. You ever see, you go to a lake, a pond, you see a fountain, and you think, oh, it's decorative. Yeah, it's not decorative. It's actually intended to break up algae mats. So that could probably be integrated if we were going to have something like that. But that would do a good job of breaking up those mats, is the fountains. And then we are talking to a professional pond and lake management company. In fact, I think that's their name, Pond and Lake. We are talking about an algicide application this year. They use a non-toxic formula. It's actually safe to swim immediately after putting it in the lake, although they recommend waiting 24 hours, just as an abundance of caution. They came out and took a look at the lake recently, and they actually said we shouldn't be applying it just yet. We should wait until the temperature increases, because I think we negotiated 2 applications, and they said don't waste it yet. It's not really that bad. They said let's wait until the temperatures are a bit warmer. And we'll do one sort of at the beginning of the summer, just before the beach opens for swimming, and then maybe one right at the end of the swimming season. So that's the plan. Is that we're going to experiment with algicide. And again, this is these horrific pictures. This is dredging. This is the extreme future management alternative. If nothing else works, and the lake continues and becomes much more eutrophic, the only solution is to remove the sediments and get all that phosphorus out of the system. But that's an extreme recommendation. Obviously, it's done in many places. I took these pictures at a lake in central New Jersey that had just it was hopeless, and they had to do that. It's very expensive. It's very disruptive. We don't recommend that, but that is the ultimate solution to removing nutrient sediments is dredging. Again, just some additional recommendations. We think there could be some benefit in understanding the hydrology better, especially the groundwater and the stormwater. That would involve bringing in a specialty firm, a hydrology firm, doing that. Potentially installing what we call green infrastructure, stormwater detention ponds, vegetated swales in areas that we identify, again, through hydrologic studies, are what they call critical intercept areas where stormwater is making its way over. That's commonly done in urban systems. And then I think Hudson does a good job with The street cleaning and the litter patrol, as far as I know, I noticed when I was driving in today, there's signs about, don't let your pets poop or pick up your pet poop, or if there's a fine probably associated with that, that's a good step in that direction. But that's important too, because it's a sort of chronic, what we call a non-point source of nutrients, is litter and pet waste and that sort of thing. And then we just provide education with also on fertilization, so we're not constantly pumping phosphorus into the watershed if it's unnecessary. And I just want to acknowledge, again, the funding sources. Couldn't do any of this work without the DEC Environmental Justice Community Grant. Two rounds of funding from the DEC, which is fantastic. And all volunteers, especially, who came to the training sessions and went out with us and they collected the data, especially the young lady who just knew exactly how to collect that water sample. Like I said, this has been a really rewarding project for us to work on, and we've had a lot of fun working on it. And we've got a final report that I'm going to take one last look at. So it's perfect, and we're going to send that to Friends of Oakdale Lake. And I don't know, does that get distributed to the public, and the public access that report?
What we've done historically is make it available online,
Yeah,
and then
perfect.
give a copy to the mayor's office
Okay.
and to the library.
So if you want to.
So that's what I think. Oh, and the youth department.
Yeah, so if you're interested and you want to dig a little deeper and read about all this at your leisure, contact Tamara and she'll guide you to the final report.
Contact Peter Frank.
Okay.
So good. We also acknowledge Vanessa Barrett, who ran all of the amazing volunteer. She was our volunteer coordinator and did all of our citizen science work and sent samples into the Upstate Freshwater Institute tirelessly.
All right.
And Dave Gaza.
Oh, yeah. Thank you. Do you have time for questions?
I think so.
Yeah. Do we have any questions?
I have a question, and I've been swimming out there on some days, and I get out near the aerator. Sometimes there's just this incredibly bad smell that comes, and I wasn't sure what that was.
Well, it's the aerator doing its job, frankly. It's stirring up the sediments and it's methane. So, yeah, you're just increasing the amount of methane that gets released. That means oxidation is taking place, which is a good thing.
I've heard that from another swimmer also, who, and maybe this is an argument for putting some more information about what the aerators do. Because another swimmer who lives nearby said verbatim, the bubbler that makes the harbor smell no bueno.
Yeah, I hadn't heard that before. That's interesting.
I was like, yeah, actually it is bueno, but I definitely.
But those aerators, again, they do work. It takes a long time to see some of the results. The immediate results are, increased oxygen, but what you're really trying to do is you've got this muck layer at the bottom of the lake. It's just we call it black mayonnaise. It just accumulates. Again, it's years and years of phytoplankton blooms, blooming and dying, and it just accumulates in this fine brown black sediment. And what happens when you're oxygenating the sediments, you're just increasing opportunities for we call aerobic bacteria to start eating away at that. And one of my colleagues lives on a lake in Broome County, out near Binghamton, and they installed aerators like 10 years ago. And they have actually gone out and measured the depth of that sediment layer, taking cores, and they have noticed a reduction, several inches of that muck over time. It didn't happen in 1 or 2 years. It took nearly a decade to happen. But there's definitely that oxidation is taking place, that decomposition is being accelerated, and the amount of muck, because they didn't want to dredge either, right? So dredging is, immediate gratification, take it all out, but it's not. But if you have the patience to do the oxygenation, and you can wait a decade or so, you will see a reduction in that muck layer, meaningful reductions.
I think that's a good point just to really focus on, is that there's a balance between the ecological benefits of Oakdale Lake versus some of the aesthetics that we wish to see in a lake that we're recreating at, especially swimming. And I think our project has always been trying to balance those two And there's no magic wand moment it takes years for eutrophication to show up like it is, and it will take a while to address the issues in like an ecologically sensitive way that also addresses the community's need to recreate at the lake. And I just think like that's one of our most important takeaways of the project. And hopefully in the years to come, as management of the lake moves to Friends of Hudson Youth as well as the Hudson government, we will start to see more and more beautification impacts from the work that's being done.
No, we didn't really introduce Kate here, but Kate is an integral part of this project. She worked at Great Ecology for quite some time, and she led phase one. She, from everything from the proposal to she obviously you saw pictures of Kate. She did all the citizen science training, and she's since moved on to a different job. She works for the Billion Oyster Project now in New York City, but she lives here in Hudson, and she's been involved in phase two throughout the whole process as a consultant. So
And also deeply helped me as a volunteer coordinator.
yeah, absolutely. So if you see Kate, just thank her for her service to the lake. Yes.
Is there a social historical aspect of this or foundation, or is that not science? I mean, I've been seeing things that use art history to say how the lake was depicted, maybe, or just photography over the last 150 years, whatever, from the beginning, as part of the story of what it's gone through.
I don't really know too much about that. Kate, could you speak to that more?
So we didn't have a specific the grant itself has like the socioeconomic portion to it for like the environmental justice aspects of this resource and the communities that are using it. I think there have been some exhibits at the library that show like I think the park was established and the lake was established by the National Guard. They built it. They impounded Spring Creek, which is the feeder creek that used to flow all the way to the Hudson, and you see Underhill Pond, and then you see Oakdale Lake. And so there are historic or archived photos of that, and they've been on display rotating. It'd be a really interesting project. We do have some plans to put in signs at Oakdale Lake to give a little bit more awareness to the project that's been going on and the systems, and part of that eventually could be some more ties to the creation.
That's a really good point, though, because something that's in vogue right now in ecology, and for good reason, is dam removal. There's a lot of historic mill dams that no longer serve the purpose that they were originally intended for mills and whatnot throughout, especially the Northeast in New York State. And there's a lot of interest in removing those dams to allow fish passage, especially if you have like migratory fish like herring runs and things like that. But there's always a lot of opposition from the communities to dam removals, because the communities are used to having a lake. So when you do a dam removal, you convert a lake to a channelized system, right? And a lot of times these projects are proposed without really taking into consideration that the lake is an important part of the community for fishing, for ice skating, for boating, for whatever, and that they sort of gets dismissed. But a lot of times there's opposition to dam removals because of cultural, socioeconomic, historical aspects of ponds. I've seen this in Pennsylvania, for example, where people, I know one project in particular, a colleague of mine worked on, they were very excited about a dam actually collapsed on its own. It was so in disrepair that it sort of created an opportunity. But instead of repairing the dam, they decided, well, we're going to bring it back to a channelized system. But a lot of people in the community said, we'd rather you fix the dam because we liked having the pond. Ultimately, they did create it to a channelized system. It was a very successful restoration, but there was there's a problem there. A lot of elements of the community were not on board with that. And if you don't have the stakeholder buy-in for environmental projects, it's an uphill battle. It's an important, but we don't, as a scientist, we're not really trained to engage the public or that's a whole separate discipline, sociology. But I can't tell you how many projects I've worked on where we've got to engage the stakeholders early before we get too far in the planning process. Otherwise, the project can really get derailed. I'm sure you've seen this, but with your work now especially, right, every day, yes. Tomorrow,
I might be misidentifying it, but I think we're having another crazy muskboard year.
Okay.
And like there's a really, I pulled a lot of it out
It
in
might-
anger the other day.
in anger.
But, so is that like,
It's native,
yeah, I know, but it's awful, and like, you don't want it in your legs, and kids would like, it's so
Yeah.
gross. So is there like any discrete way that we know of either stopping that from happening, or like, I remember when we were pulling up the pondweed, you were like, oh, if we get it before it senesces,
right?
that's like the great
Well,
time.
when it senesces is when all the nutrients come
Right.
out, so, yeah.
Is there something in the muskwort life cycle that we can identify early and then nip it in the bud? Or
It has
is it
such
just like
it
part
has
of
such a
this big-
short life cycle, I don't think it's worth it. It's there and then it's gone.
When's it gonna be gone?
I don't know, probably in a couple of weeks. Yeah.
Before swimming season,
Yeah, hopefully. Yes.
So you said the fish eat the phytoplankton, right?
Larval fish will graze on phytoplankton. Some fish, as adults, will graze like herring and whatnot, but yeah, some do.
So can you eat the fish?
Can you eat the fish?
Yeah.
Are you saying, can you eat the fish if they've been grazing on a harmful algal
Yeah,
bloom?
yeah. You know, like during, is it an issue? You know?
I've never heard of that being an issue in freshwater systems. It's an issue in marine systems. It's always been. So that's why you're not supposed to eat things like barracuda or other top level carnivores in marine systems, because they some of the toxins in marine systems bioaccumulate, which means they increase in the concentration as they go up food web. So like a fish will eat it, it'll be fine, but then another fish will eat that fish. But every time it gets consumed, it increases. But that's not an issue in freshwater. I've never heard of that in freshwater system.
I think,
It's a totally different organism in marine systems. That's a problem, because people read in the paper about red tides and harmful algal blooms. Completely different organism than in freshwater. It's what they call a dinoflagellate in marine systems, and that can be pretty awful. Like I've experienced it in Florida, on the beaches, where it blooms and then it washes, the surf washes it on the beach, and it dries, and you get like respiratory, if you have asthma or any kind of lung disease, you can really get sick from that. But that's very different than what's going on there.
I was just gonna say handling a fish, like, you don't really wanna be touching the water in a
Right.
harmful algal bloom, so like, you wanna be sure that you're cleaning the fish really well and not.
Totally.
Yeah,
I was
all
just
that
thinking,
stuff.
because you kind of discover these things after they've happened, right?
Yeah.
So I wonder how kind of cognizant of that you would have to be while fishing
Yeah.
in the summer period. Like,
Yeah.
oh, is it even fine right now? You
Yeah.
know, but
I don't think it bioaccumulates like
not
that
that
in
No.
fish, no,
No.
so like, yeah, if it was clean and everything,
Yeah.
Yeah.
probably.
Yeah, again,
Right.
marine
Yeah.
bioaccumulation, that's a totally different organism,
Yeah.
different life cycle. But again, if I was fishing in Oakdale Lake and I wanted to catch some bass or sunfish and I wanted to cook them, if I saw the green paint looking stuff, I'd kind of maybe come
Yeah.
back another day. Yeah.
I wouldn't eat mussels or anything,
Sure.
like during that, because they're filter feed and we're not really accumulating that.
You shouldn't eat freshwater mussels, period, because
Yeah.
they're so full of parasites. that
Exactly.
If you go to the emergency room, you're dead.
Jesus Christ.
Don't ever eat freshwater clams or mussels.
I don't know if I would be like subsistence fishing in a system like this, but yeah.
Yeah. Agreed. Yes.
So the last couple of years, we've removed Phragmites from the outside of the pond.
I was there that day. when we
Yeah,
did it, yeah.
but we've actually seen some degradation of the paths around the lake where we did that.
Okay.
And
From the
I'm
equipment?
wondering if we may have inadvertently contributed to phosphorus levels increasing. Like if there's more runoff into the lake, the places where those plants were removed.
Well, I suppose that's possible. The Phragmites aesthetically doesn't look very good,
Right.
but it actually does do a good job of intercepting what we call filtering out nutrients.
So could we replace them with native plants?
Yes. So
Yeah.
I would say bring cattails, exactly. So your cattails are your native emergent plant, that grows kind of in a similar place and a similar form to Phragmites. So yeah, if you could promote cattails where the Phragmites would, that would do that. I remember I was there when they were doing the Phragmites removal, and I mean, they were as careful as they could be, but I remember there was pieces of the roots and rhizomes all over the bad place, and I was kind of wondering if that was how much it's gonna come back from that, because you just can't get it all. You know, you try, but it's sort of a messy procedure. Yeah. So, and the equipment they were using, you can't help but compact the soils. It's heavy equipment. So, and you can't pull it out by hand, you'd be there forever. So it's a challenge, yeah.
I have one more question too. Is there any reason to not stock Oakdale with trout if we wanted to bring back the fishing group?
There's no reason not to, but I want to understand, like I said, we haven't done a fish survey there. I want to understand if we can, if they're there. And again, with the increasing temperatures, I wouldn't look at Oakdale Lake and say, oh, this is a great place to put trout. I think I'd promote Oakdale Lake as the best lake, a warm water fishery lake. It just, even though there's trout there, and they're there because if you didn't have those springs in that deep area, I don't think they would last outside of the stocking season. But there's plenty of examples of lakes that are stocked with trout where those trout are never intended to survive and to reproduce. They're just there to be removed, quite frankly. Is that it?
I have one last question.
Okay.
Did you do watershed mapping, within the park and beyond the park
We-
to determine what the actual watershed?
We did.
that's-
There's actually phase one, that's how phase one started off. We did a lot of watershed mapping. That was, all those maps and descriptions are in the phase one report. Tomorrow, is that still available, or?
Yeah, both.
There's also
Oh,
There's
okay.
that.
watershed map.
There you go.
Oh,
Yeah.
beautiful.
Yeah, to take a look.
There it is.
Phase
Yeah, it's
one.
right there. It's
Yeah.
both in the environmental review, which is a really, really huge document that I gave you a couple of weeks ago, and it's in the final report, which
Smaller one.
is a smaller one.
I can share a hard
Okay.
copy of the
You
report
have
with you.
but you have part of both are also in the mayor's office and the library. And they were both on our website, but I think our website is now like an anime, or Roblox game or something, but soon it's gonna be all up on Peter's website.
We did the surface watershed map,
Right.
not, and what is the mapped aquifer, but, in terms of groundwater flow, that's a bit of a different beast of a study, and it would be interesting to do, but it's a different, expertise for sure. But I think that's, like a known unknown at this point, is there is a lot of groundwater interaction, and what that looks like, and the exact extent of it for phosphorus inputs and stuff like that is something that could be.
Thank you so much, Dave, and thank you
Thank
so
you,
much.
Tamara. Thanks for the opportunity. Like I said, we really had a lot of fun. We're in Oakdale Lake.
So all of this will be